So next, we're gonna talk about stability. So before this, we talk about determinacy, which is R equal to 3n. So R less than 3n will be unstable because you have your reactions less than the three times the members. So it becomes unstable because the support is not enough. So if R is more than 3n's, it will be unstable if member reactions are concurrent or parallel or some of the components form a collapsible mechanism. So you become the structure become unstable if they are concurrent or reactions are concurrent or parallel or there is a collapsible mechanism join join between in between the members which causes the collapse. So in general, structure will be geometrically unstable. That is, it will move slightly or collapse. That is the definition of unstable. The structure is not static. It can move slightly, or it can totally collapse. If there are fewer reactive forces than equations of equilibrium. So basically, in general, it's like you don't have enough support for the beam. For the beam, for example, beam being placed on pin joint or on roller, so the beam can move slightly or even collapse. Or the beam is a two members like trusses, but not enough to form a stable trusses. It's also unstable, and this is based on the equations. Enough reactions, instability can also occur if the lines of actions of the reactive forces intersect at a common point or are parallel to one another. So, if the reactions is um, parallel to one another or intersect, you have a support at an angle, so the reaction forces intersect at a common point. So this is the example of the unstable beam. The beam is unstable since the three reactions are all parallel. So you have a parallel uh, reaction forces at A, B, and Y because all are rollers. So based on the rules that we've talked about in the previous slide. So when you have parallel forces only, so the beam become unstable. And also it is all rollers, so you can move around. So you need to add uh, a, a, a pin joint, for example, or a fixed support here at C or A to make the beam. So statically indeterminate structure. So numbers of unknown reactions or number of internal forces. So number of unknown reactions AY, AB, AY, BX, BY, CY, BX, so on, or internal forces, um, which when you slice the beam, so there is an internal force. So the internal forces or the unknown reactions, so the number exceed the number of equilibrium equations as we talk about in the determinacy. So your R is more than the 3n. This arise due to added support. So when you add, for example, like previous slide, you add support to make the structures stable. So the structure becomes statically indeterminate. So statically indeterminate structure arise due to added supports or members or by general forms of the structure. Column and beams are put as continuum members. So because it is monolithic and call it monolithic, so your beam is jointed to the column monolithically because you cast the concrete in one go in a not in one go in a continuous structure, so it becomes a continuous members. uh, Hence it becomes a fixed support at the column, the joint between column and beam becomes a fixed support, and then the structure is stable but statically indeterminate. So one of the methods to solve for this is to use the method of consistent deformations, um, which is using force method. The first one is using force method, but it is based on deformations. We analyze the deformations that is experienced by the beam so that we can add new equation based on deformation so we can solve for the unknown forces. So take a look this on the next slide, on the next video, and see you in the next video.